Hello and welcome everyone. In this video, we will look at Gauss elimination method for solving a system of linear equation. There are two main steps in this method, elimination and back substitution. In the elimination phase, we use some elementary row operations to transform the augmented matrix built with the coefficient matrix A and the output vector B into its row echelon form, such that instead of A, we now have an upper triangular matrix and C is a vector of the same size as B. In the back substitution phase, now that we have an upper triangular matrix, we can easily find the value of x in the last row by dividing Cn by unn. We can then proceed to the row above, which is at index n-1, and substitute the value of xn to find xn-1. And we can do so for all the rows above by simply using this formula. Now, if we have an augmented matrix like this, where all the diagonal entries are non-zeros, Gauss elimination method will work fine. But when we have a simple reordering of the same problem, Gauss elimination method will fail as the diagonal element in the first pivot row is 0. In this case, we use pivoting, in which we basically check the relative size of elements in the column containing the diagonal element of the pivot row, and if there is any row after the pivot row whose value is larger than the diagonal element value, we swap the current pivot row with the row with higher value. Let's see how we can implement this method in Python. We write a Gauss elimination function that will take the coefficient matrix and the output vector as inputs. On line 61, we check the rows and columns in the matrix A. On line 66, we check the maximum absolute value in each row, which we use in line 72 to find the row with the highest relative size element. Now, if this is not the same row as the pivot row, we swap the pivot row with this row. On line 83, we check if the matrix is singular or not. On line 87 to 89, we use the pivot row and clear all the elements in the column containing the diagonal elements for the rows after the pivot row. Once we have transformed the coefficient matrix into an upper triangular matrix, we use the back substitution formula on line 94 to find the values of vector x, and then we return A, B, and the solution x. Let's see how we can solve this curve fitting problem using the Gauss elimination method. We import the Gauss elimination function from utils that we discussed in the previous slide. On lines 13 to 14, we write the system of equations by putting the x and y values of the 3 points in the quadratic equation. On line 24, we then use the coefficient matrix and the output vector as input to the Gauss elimination function. The solution in this case is 3, -2, and 4. We then plug these values for A, B, and C in the quadratic equation and plot to see if its graph passes through the 3 given points. And as we can see, it does. In the next video, we will discuss Gauss-Jordan elimination method, which is an extension of the Gauss elimination method. Thanks for watching. I hope you liked this video. Please subscribe and see you in the next video.